Okay, for this next video, we are going to quickly run through experiment 3. And again, the first experiment video really shows you how to do this. And this video is mainly to show you the differences, what you need to run this exact experiment, how it's different than the other two that you've run, and also to reiterate a couple of important points. But let's get started. Again, we'll remind you, you need to reset everything because here we go back to the website. This is the end of experiment 2, right? So we're done with experiment 2. We don't need this data. We don't need these parameters. We need to start fresh. So I'll hit the refresh button, and there we go. We're starting from the beginning, right? Now for experiment 2, we're looking at mutations, okay? So we're gonna look again at this population of fish, these orange fish, these spotted fish, these white fish, and we're gonna see how they change over time when everything else is equalized, so to speak, right? Nothing is changing as far as migration. Nothing is changing as far as sexual selection or natural selection. We're strictly looking at how mutations are going to change the population. And this right here, these are just written instructions on what I'm about to show you. So under the evolutionary parameters section of the website, you're going to choose, or you're going to see the section that says mutation rate. And then under that section where it says mutation rate, you're going to see the choices big R to little r, and you're also going to see the choices little r to big R. And what we're going to do is we're going to choose, we're going to select the up button on the portion that says big R to little r. And again, obviously, I'm going to show you how to do this in the video. Right now, I'm just reading through it. And when we do that, the change you should expect to see, so the way you know it worked, is that you're going to see the number that initially was 0, it's going to change to 0.001. And as I keep saying, these numbers mean nothing if you're just reading them and writing them down. I want you to understand what they mean. So what does that number mean? What does that change in the number mean? This means that with each generation, remember each of the 100 generations that you're going to observe, there is a mutation that changes a big R allele to a small r allele 1% of the time. So, and these aren't the numbers we're working with, but that would mean, you know, if you had 100 R alleles in the first generation, then when you move from the first generation to the second generation, one of those big R alleles is going to change to a little r alleles just once, because 1% of 100 is 1. But anyway, again, I'm going to show you how to actually change your parameters. And then I will, again, show you how to get your data, collect your data, and actually start the experiment. Because, again, I want to remind you, the whole purpose of this experiment is to test your hypothesis, because you had to guess how does the population change due to mutation, right? Will the white fish increase? Will the spotted fish increase? Will the orange fish increase? Will there be no changes? Whatever it is, the purpose is to test your hypothesis. And to test your hypothesis, you're going to run the experiment. We're going to fill in, we're going to use that experiment, that simulation, to fill in this data. Then we're going to use that data to calculate this. And then from that, we can have an overall look at the results and see if your hypothesis was correct or not. But here we go. So we need to collect data. Let's go to the website. As always, I want to remind you, we want to hit run experiments, but when we do, the experiment starts right away. So we need to be prepared to hit the pause button right away. So here we go, click run experiments, click pause. All right, I did that as quick as I could. As a reminder, all these parameters up here don't need to be changed. They're exactly where they need to be. Also here, for some weird reason, it always starts with a migration rate of 1, which we don't want because we're not looking at migration right now. We're not looking at gene flow. That was the last experiment. So I'm going to click that and change it to 0 because, again, we're not looking at gene flow. We are looking at this, the mutation rate. And like I said, we're going to change this one right here, the one that says big R to little r. We're going to click it up once. So then our new number went from 0 to 0.001. And again, what that means is 1% of the time, you know, for each generation, 1% of the big R alleles are going to mutate to a small r. There will be no changes from small r to big R, so we'll just leave that as a 0 as they are. And as always, because we're not dealing with natural selection, these will stay the 1. They're all equal, right? 1, 1, 1, meaning there is no advantage to being any of the colors, and there's no disadvantage to being any of the colors. And same here, assortative mating. So again, there's no sexual advantage to being one color or the other. So at this point, all of our parameters are set. So before we can start the experiment, again, we need this initial data. We need to know what the numbers were before we start the simulation. So we come here, we hit to data. There it is. That's all the information we need. We take this information that's right here and we insert it into this portion of the table. And once we've filled all this out, we are then ready to run the experiment. As always, we hit the play button. Again, it's very slow. I always like to speed it up because I've done this 1.5 million times and I don't enjoy just sitting around watching it. But even when it goes to full speed, you still have to sit around and wait for a little bit. So as we do, as always, we can see the population size fluctuating, but generally staying the same. We can see that the whitefish, the proportion of whitefish is really getting higher. The proportion of orange fish has gone way down. And of course, the heterozygotes, the spotted fish, which are in between the two, are kind of neck and neck with the whitefish. Again, we're trying to hit 100 generations. So I paused it when I saw it hit 100. And you can see I was close. I actually hit 102. And again, that's just like the other ones. That's close enough. So I'll go over here and I will make that correction. It's technically after 102 generations. And again, I'll remind you the same thing. You just need a minimum of 100 generations. If you feel like doing extra, you go right ahead. Just make sure you update this portion of your table. Now then, we're done running the experiment. We now have the data for after the experiment. So we take all this data right here. We enter it in right here. At that point, you will then have all the data you need. You're done running the simulation for experiment 3, right? You're done running the experiment. You're done collecting the data. It should all be right here, which means at that point, you can then calculate the differences between all the initial and afters. And then once you calculate the differences, again, you can calculate the percent changes. And then once you've done that, then you're done, right? Now you're able to look at your data and figure out, was your hypothesis correct or wasn't it correct, right? Which allele increased, which allele decreased, which genotype increased, which genotype decreased. These are all the things you can answer after you've collected your data and made some calculations. So at that point, you are done with experiment 3.